Hello, I welcome you all. The problem reads the car has an initial speed of v naught equal to 20 meters per second. If it increases its speed along the circular track at s equal to 0, at equal to zero point 0.8 s, where s is in meters, determine the time needed for the car to travel s equal to 25 meters. The second problem, the car starts from rest at s equal to 0 and increases its speed at 80 equal to 4 meters per second squared. Determine the time when the magnitude of acceleration becomes 20 meters per second squared. At what position s does this occur? So both these problems are coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. Quick reminder of the basic kinematic equations. We have velocity, which is the time derivative of position. We have acceleration, which is the time derivative of velocity. And from the two equations, we have one derived equation, a ds v dv. And from these three basic kinematic equations, we're able to derive quite a couple of equations depending on the boundary condition. One of the most common equations that we usually use is when acceleration is constant at t equal to 0, we have s naught and v naught, and from these boundary conditions we can derive these sets of equation s equal to s naught plus v naught t plus half act squared. So v is equal to v naught plus act, and v squared is equal to v naught squared plus 2ac s minus s naught. Okay, so here we go. So what do we have? So let's say we have the velocity here, which is tangent to the curve at that point. All right, and then we have acceleration in that manner, and also another component of acceleration like so. Okay, let's call this one an, that's normal acceleration or centripetal acceleration. This is tangential acceleration, and then this one is tangential velocity. Right, so let's begin the work. Let's start with case 1, which is 12-128. So in this particular problem, what do we have? Here we've been told that v naught is equal to 20 meters per second, and we do have at equal to 0.8 s. Alright, let me just rub the units. Okay, and we also have s equal to 25 meters. Okay, and of course our s naught is equal to 0. Right, so what do we do here? Of course, here we're being asked to find the time. So what we need to do is find the velocity, use that to find the time. So let's start with this equation because our acceleration is a function of our position. So let's use this equation. So we'll say a ds equal to v dv. Okay, so for this one we can integrate this from 0 to s. Okay, and then velocity from v naught to v. Alright, so acceleration is 0.8 s. Okay, yes, integrating it from 0 to s, and then we have our velocity. Our initial velocity here is 20, right? To v. Alright, so working on this one, we get 0.8 s squared divided by 2 equal to v squared minus 20 squared divided by 2. And therefore, our V is just going to be equal to square root of 0.8s squared plus 20 squared. So this is our velocity. So once we found our velocity, let me just create a boundary. Once we found our velocity, we'll use our velocity now to compute let me close off this part here. Let me close it off. Sorry, I close off this part. Alright, so there we go, like so. Great. Okay, so once we have that, so what I'll need to do now is to use this equation so that we are able to find the time. Alright, so we'll say our V is equal to time derivative of position, and writing this, we can write it as a dt, okay, equal to, since our V is a function of s, so just say ds v. Okay, therefore this just becomes, and then we integrate this from 0 to t, right, from 0 to t, and then this one is from 0 to, not 0, right, to s. Okay, so what do we have? So we'll have a t there like so. We'll have a t equal to integral from 0 to, our s is 25, and then we do have, this is 1 divided by root of, this is root of 0.8 s squared plus 20 squared. Okay, then ds. Alright, so this you can solve it using different methods. For me, I'm going to use Simpson's rule, which is a numerical technique for solving definite integrals. So let's use Simpson's rule. You don't have to use this if you have already some table, or if you can solve this quickly. Alright, so we use Simpson's rule to solve this. So what is this Simpson's rule? So Simpson's rule states that, I'll write this, given our function, which is a function of s, there we go. So given this function, which is 1.8 squared plus 20 squared, okay, so we can say our integral from a to b of our function is approximately equal to ds over 3, and then we have what do we have? We have f of s 0 plus f over 4, f of s 1 plus 2, f of s 2, okay, then plus another 4, maybe f of let's say n minus 1, and then maybe the last one s of n. Okay, where let me go up there. Sorry, let me just go up. I just make a bend a little bit there. So here, where delta s is equal to b minus a over n, and n is equal to number of even subdivisions. Okay, So basically this is what we intend to do. So if we are to draw this, so now let our n be equal to 4. Okay, therefore our delta s will be equal to our b. In our case, we are integrating from 0 to 25, so our b is equal to 25 and our a is equal to 0, right? Therefore our delta s is just going to be equal to b minus 25 minus 0 divided by 4, and this is just going to be equal to that's 25 divided by 4. This is equal to 6.25. Right. Okay. So there we go. Seeing this is our function here, f of s. So now if we are to show this on the number line, if we are to show this on the number line, this is what we have. How many do we have? 1, 2. All right, let me get a much slimmer line. Let it be straight. So maybe from there, 3, 1, 2, 3, 4, 5. Okay, somewhere there like so. Right, so let's say we have this one, we have this one, this one, this one, and this one. Okay, so this one here is, so we are starting from 0, then 6.25, then this one is at 12.5, and then we have 18.75, and then finally we have a 25. Then this one is our 0, this is our 1, 2, 3, 4. Okay, right. Of course, and then this interval here, I mean this difference here is our delta x. Okay, right, so let's get moving. So there we go. So we have, that is, we are moving from we're integrating from 0 to 25 of fs, okay, fs ds, and then this is approximately equal to what did we say? This is 6.25 divided by 3, and then we have f of f of 0 as the first value, and then plus 4 f of 6.25, then plus 2 plus 2 f of 12.5, then plus another 4 f of 18.75, and then finally no coefficient, the last one 25, then we close. So let's begin to find these values. What is f of 0? We will plug in 0 into this function here. Okay, so the function is, let me just move it, I move this maybe somewhere there like so, right, and maybe this I move it just a little bit down like so. Okay, so let me write the function again here. So the function we said is f of s is equal to 1 divided by root of 0.8 s squared plus 20 squared, right? So we are going to be plugging in all the values of s into this function. So let me write it in advance. 1 divided by root of 0.8 times, in brackets, start with a 0 squared plus 20 squared, and then we close bracket. All right, is that okay? It is. So this one gives us a 0.05 and f of 6.25. Just enter this value there, 6.25, and we have a 0.04815. Then f of 12.5. Okay, 12.5, like so. So we have a 0.04364. 4364. Then f of 18.75. Okay, 18.75. We have a 0.03831. Right, and then finally we have a what do we have? A 25. Right, so f of 25. This gives us a 0.03333. And then finally, let's find the time. Our time, therefore, which is equal to integral from 0 to 25 of our function of s is approximately equal to, let's work it out now, 6.25 divided by 3 times, open bracket, 0.05 plus 4 times 0.04815 plus 2 times 0.04364 plus 4 by 0.03831, and then finally we have a plus 0.03333. All right, and then we say this. So this gives us a 1.08 seconds. Let me repeat this again. So we have a 6.25 divided by 3. Okay, then we do that again. One more step. 0.05 plus 4 times 0.04815 plus 2 times 0.04343 4364 plus 4 times 0.03831 plus 0.03333. Okay, 1.08. Okay, so this is the time for the first problem. So we are going to solve the next problem in the next video. so that we do not spend so much time. So this is an approximation using Simpson's rule to solve this definite integral for problem for case number 1. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.